Hello, welcome to our discussion number one, where we're going to discuss chlorine monofluoride versus chlorine trifluoride. My name is Angela Harper.
And my name is Emmanuel, and Group 1 also includes Abdul, and we will continue on with this discussion.
First, I want to talk about the Lewis dot structure, which was invented by Gilbert N. Lewis in 1916. It helps us visualize the bonding and the distribution in small molecules. The bonding patterns in the molecules, dots are for the valence electrons and lines are for the covalent bonds. They predict the molecular geometry. Of course, we know that any atom inside a molecule has a charge, and this charge is called a formal charge. There's many similarities and differences between the two. The similarities between chlorine monofluoride and chlorine trifluoride is that they both possess a zero at most stable Lewis structure, and that they both have lone pairs of electrons. The difference between the two is the number of atoms. Chlorine monofluoride has just one atom that bonds fluorine and chlorine together, whereas chlorine trifluoride has three. The molecular geometry is different. You've got chlorine monofluoride that has a linear geometry, whereas chlorine trifluoride has a T-shaped. The number of bonds are different as well. Chlorine monofluoride has one bond between them, and chlorine trifluoride has three. Don't forget, chlorine trifluoride has expanded octite.
I will start talking about the resonance structure. Chlorine monofluoride has no resonance. And just as a quick definition of resonance, resonance mean that one compound can have more than one Lewis structure. So as we said before, both the compounds do not actually have any resonance. Chlorine monofluoride does have one ClF single bond, and it doesn't have any delocalized electrons. ClF3 on the other side does have one Cl bonded, but it's bonded to three F atoms, which makes the T shape. It does have an expanded octet, and it doesn't have any shifting bonds. Stability is a major thing we should talk about when we compare both compounds. ClF is very stable, and it does have very strong ClF bonds, and it's used in industry, such as cleaning industry. It's highly used in cleaning products. Everyday chlorine that we use to clean is one of the applications of ClF. ClF3 on the other side is very, very reactive and highly reactive, and it's less stable. It can ignite things without even the exposure of oxygen, and it must be stored carefully. The role violations, ClF does follow the octet rule, and both because both Cl and F have 8 electrons, ClF3 does break the octet rule, and it has 10 electrons in Cl, and it's allowed in elements in period 3 or higher.
Now we'll talk about the molecular geometry and the polarity. There's a stark difference between these two molecules. For chlorine monofluoride, it has a linear geometry, whereas chlorine trifluoride has, as previously mentioned, a T-shaped geometry in the 2D plane, according to Vespert theory. But if we were to be more specific with regards to the geometry, looking at a 3D aspect of it, it has what's called the trigonal bipyramidal molecular geometry. And because both chlorine monofluoride and chlorine trifluoride only have ClF bonds, which have an electronegativity difference of 0.8, both molecules are polar and thus soluble in water. But we'll talk about the solubility in a little bit. Now, for the correlation of structural features of molecules with listings and matchings of physical and chemical properties. For both chlorine monofluoride and chlorine trifluoride, they break down into chlorine gas and fluorine gas. Chlorine gas is greenish yellow in color, while fluorine gas is slightly yellowish green. And also, both chlorine monofluoride and chlorine trifluoride are colorless in their gaseous form. However, there's a difference in their color. With chlorine monofluoride, it is slightly yellow in liquid form. Another similarity between the two is that when dissolved in water, chlorine monofluoride is highly reactive due to the high amount of energy required to break the ClF bonds because of the electronegative elements in those bonds. Breaking those down create hydrofluoric acid in water, which is a very strong acid, and chlorine gas, which is a volatile gas, and heat, making it an exothermic process. The very stark difference here is that chlorine monofluoride is much more stable than chlorine trifluoride due to the much more simple linear molecular geometry. And I mentioned how there's a difference in color between chlorine monofluoride and chlorine trifluoride. In liquid form, the monofluoride is yellow in color, more yellow. Trifluoride is more green in color in its liquid form. And the same thing that applies to the monofluoride form applies to the trifluoride form as well when it comes to the solvation in water, in terms of it being highly reactive, and also the molecules and the heat that's released, but not the amount of heat, of course. However, with chlorine trifluoride, because of its more complex molecular geometry, it is highly, highly volatile, to the point where any contact it makes with organic materials can cause spontaneous combustion.
So didn't you do some research about an instance where that example can be shared?
I did. So in World War II, there was actually an Axis power that experimented with chlorine trifluoride as a nuclear weapon. However, due to its massive volatility, they realized that they could even handle it. They couldn't tame the beast. So they ended up banning it from use. And what scientists have later on discovered through experimentation is that the only way to really contain such a volatile compound is by containing it in a tank that is made from a metal alloy that contains steel, nickel, aluminum, so on and so forth, as well as coating the inside of that tank with fluorine gas in order to make sure that everything stays stable. Otherwise, we're talking cities, nations could
Complete devastation.
exactly.
Wow. So let's do a quick recap. The features of the resonant
of chlorine monofluoride and trifluoride, we started off with the resonance.
You have bond types, electronic dislocation, stability, state, industrial use, octet rule, exceptions allowed, overall safety. With chlorine monofluoride, there's no resonance. Single and chlorine and fluorine bond. It's very stable. It's gas at room temperature, used in cleaning processes, and it follows the 8 electrons on Cl. Not needed and it's much safer. Whereas chlorine trifluoride, it has no resonance. There's 3 chlorine fluoride bonds, which make it a T shape. It's very, very reactive and toxic. It must be stored very carefully. It can be corrosive and explosive. It's used in special rocket fuels and nuclear work. It breaks the 10 electron rule, and it's known as the expanded octet. And yes, period 3 electrons can expand octet. It's dangerous if mishandled.
Absolutely.
So let me give you some final thoughts about this. Chlorine monofluoride is very simple, it's very stable, and it follows all the rules. Whereas chlorine trifluoride is powerful, it's reactive, and with an expanded octet. There's no resonance in either. However, one thing you need to remember, as he said, you got to be very, very careful with chlorine trifluoride. It's no joke.
Now, as the professor likes to do with us students in class, we have a pop quiz.
Pop quiz it is. Let's test your knowledge. Let me know. In a Lewis structure of chlorine fluoride, the formal charge on Cl is what? And the formal charge on fluorine is what? If you remember what we said, we told you that there's zero charge. That's because you take your valence electron count and you subtract your bonded and non-bonded. And when you do that, you have 7 minus 6 bonded, 1 non-bonded, which makes 7 minus 7. It gives you 0. And then in the fluorine, you have 7 minus 6 non-bonded plus 1 bonded, which is also 7. And 7 minus 7 is what? 0. So the only answer to the question, it would be B, 0, 0. That concludes our great discussion, number 1, over chlorine monofluoride versus chlorine trifluoride. Again, my name is Angela Harper,
My name is Emmanuel Wobi.
and we appreciate you listening to us.